Right, in this chapter, we are going to be covering passive solar energy. So passive solar energy is generally defined to include systems in which the flow of solar energy is by passive processes, such as natural or free convection. The distinction between an active and a passive system is that a passive system uses no mechanical intervention to distribute energy, but relies on radiation and free convection. In a passive solar system generally possesses five components. There's some sort of collector arrangement to collect the energy. There's an absorber, a thermal mass, and a distribution protocol with some sort of control strategy. Passive collectors can include things such as windows or more exotic things such as a water roof. An absorber is, for example, a hard surface with a high absorptivity that is in direct path of the solar irradiation coming through the collector. And the passive thermal mass can be provided by external walls, floors, or water walls. These thermal masses usually receive the energy by solar radiation in the winter, but are blocked in the summer. So the structure has a south-facing glazing. Remember, glazing means window. If a structure has a south-facing glazing but no thermal mass, the structure is called sun-tempered. The use of extensive south-facing windows or glazing, up to 7% of the floor area, can reduce the heating capacity or the heating energy requirement, especially in a cold climate. So if the south-facing glazing exceeds 7% of the floor area, then a thermal storage mass is needed to effectively utilize the solar radiation incident on the interior of the structure. So here's some examples of different passive solar energy systems. So in the top right-hand side of the figure, there is a schematic of what's called a direct gain system. And then the bottom part illustrates how it might be integrated into a house. So basically, in this system, you have solar radiation coming in through some glazing. It gets absorbed into the ground and then circulated by free convection. So the thermal mass thickness should not exceed 6 inches in this case, and the thermal mass should not be carpeted. So two well acceptable rules of thumbs of this is that about 150 pound mass of masonry is needed for every square foot of south-facing glazing, and that 9 square feet of thermal mass storage area is needed for every square foot of south-face glazing. So this, again, can be used to help offset energy requirements for heating. Here we have a schematic and a representative example of an indirect gain passive solar system with something called a trum wall. A trum wall is a thick wall, usually constructed of masonry, and it's not designed to absorb solar radiation during the day, store it, and radiate heat during the night or on overcast days. So again, you have the solar radiation coming in, this being the wall. It absorbs the energy from the sun, stores it during the day, and then at night, from free convection, it kind of circulates the stored heat back into the room. This figure, these two figures illustrate a schematic and an example of an isolated gain solar energy system, or a sun space. So an isolated gain system is separate from the main building, but thermal mass is provided for energy storage. So again, you have here a sun space with transparent covering. It absorbs heat into the thermal mass and then radiates it inside of the adjacent room in the evening. Another important feature often implemented in passive solar is daylighting. The use of radiant energy from the sun for interior illumination so that the need for artificial illumination during daylight hours is reduced. So again, this figure here illustrates the use of daylighting for the stacks of a library, for example. This figure is interesting. This figure is a photograph of the NREL Solar Energy Research Facility, SERF. SERF is a state-of-the-art research facility that was completed in 1993. So what's interesting is that the facility faces 15 degrees east of due south and is built into the site slope to take advantage of earth sheltering. SERF also incorporates a number of energy savings features, including daylighting, window shades, evaporative cooling, and also heat recovery systems.